Hi Sandeep, thanks for attending our conference and looking forward to a close collaboration between CADFEM and AWS. You enjoying the conference so far?
Yeah, it's a wonderful conference. This is my first time coming to the CADFEM conference. It's a huge conference. You have over 700 people, I believe. So wonderful to see such a large community of simulation engineers come together.
Yeah, brilliant. And in your keynote speech on how customers are benefiting from running their simulations in AWS Cloud, one thing that's very clear is that AWS is clearly a leader in cloud technology. But maybe can you just talk a little bit more about what innovations AWS is planning, and in particular in relation to computer-aided engineering simulation?
So let me give a quick intro to what AWS is, first of all. So as you said, AWS is the leading cloud provider in the world today, as measured by many different things, most functionality, most secure. We have the largest community of customers and partners. And we have 200 or more fully managed services for the cloud that are available to customers. Literally millions and millions of customers use all of these features on AWS Cloud today all around the world. We operate from 33 different regions in the world, and that keeps on growing. There are more regions that are announced, and each region is essentially comprised of multiple availability zones, which each one of those is comprised of possibly multiple data centers. So, it's an enormous scale that AWS has. That's a quick introduction to AWS. Can you tell us a little bit about CADFEM to our audience who might be familiar with AWS but not be familiar with CADFEM?
Yes, for sure. CADFEM and Ansys collaborate since 1985, and as for today, CADFEM is one of only 5 worldwide Ansys Apex channel partners. And with a team of about 130 Ansys experts, we cover the whole Ansys portfolio to make sure we can sell to our customers, we can support them, and we can train them. And in addition, we are also an Ansys services partner for digital engineering. That means CADFEM is certified to support our customers in the digitalization of the engineering processes from the early conceptual phase up to the final implementation. And last not least, we are also an Ansys system integrator partner. That means we help the customer to implement and to run complex IT environments for either high performance computing as well as for simulation process and data management, starting from local hardware as a private cloud up to the official Ansys cloud offerings from Amazon or from Asia. So in summary, CADFEM is a partner for the customers to implement digital engineering.
That's wonderful. Thank you for that introduction. I should add that before I joined AWS, I was working with Ansys, and I had the pleasure of collaborating with CADFEM almost 20 years now.
We are aware.
So you're familiar with simulation and the challenges that the simulation brings, yeah?
Yes, yeah.
CADFEM is completely convinced about the benefits of the cloud technology. For all our engineering services, be it training services, be it consulting services, we have uploaded everything into the cloud, but our customers are still shy going to the cloud. So, Sandeep, what do you think? Why should a simulation engineer use cloud services?
That's a good question. So, maybe if we step back and take a look at where things are today, I would say that more than 95% of simulation is still being run outside of the cloud today.
That's true.
And this is how it has been run for the last 30 years.
Yeah.
Ansys has been around for more than 50 years. CADFEM's been around probably 40 years. Most of the time, the legacy is that simulation has been run on local machines, on somebody's desktop, or then in clusters on premises. So that's how it has been. What we are seeing is a rapid change in where customers want to run their simulations, and customers are rapidly moving over to the cloud for a few different reasons. So first of all, as I mentioned a little bit earlier, the cloud has enormous scale, which means when engineers suddenly have a need to do a lot more simulations, they're not restricted by the compute resources that they have on premises. On premises, you typically have a limited number of compute resources which you keep occupied most of the time. But on the cloud, you get a lot of elasticity. You can go up and down. From a business perspective, you can use this functionality to or elasticity on a pay-per-use model. So instead of having a capital expense, there could be an operational expense, and that can give business agility. And I mentioned in my talk, there are a number of other reasons. On cloud, we are always installing the latest processors, for example, which improve the performance of engineers' simulation job. And there is a better disaster resilience available on the cloud. So you can architect systems where you always have a system available to you. In it, you can protect against downtime. So there are reasons like that. We again work very closely with Ansys and work on benchmarking performance all the time for different solvers, whether Ansys Mechanical or LS-DYNA or Fluent, etc., so that our customers jointly get the best performance out of the cloud.
Well, performance is something simulation engineers always like. However, typical concern is the safety of their data. So what do you think, why, especially on your cloud, why are the data secure?
Security of the cloud is a question that customers have often. Security is the number one priority at AWS. We have over 300 different security-related services and compliance-related services. It's very interesting to know that AWS Cloud basically is architected in a way to maintain security standards at the highest levels for the military or global banks or even other organizations that have very high data sensitivity requirements. So it's architected for that. We comply with over 140 different security standards all around the world. So that should give customers confidence in the security of the cloud. We have a special pillar for security in any solutions that customers build on the cloud. We have a well-architected framework for that to make sure that the solutions are architected in the best way. And security is a fundamental pillar of that. We help customers, apart from providing security of the underlying infrastructure, we help customers make the right choices to ensure their security in the cloud through the well-architected framework.
Yep. Okay, thank you. So maybe you might just remind us, what is your actual title?
At AWS, I have the worldwide responsibility for go-to-market for engineering simulation related workloads. I work in the worldwide specialist organization of AWS, and I interface with literally dozens and dozens of customers who are at different stages of their journey to moving their simulation to the cloud. And I work with all our field teams around the world who are engaged with customers in supporting those field teams. So that's essentially my role at AWS.
But it's specifically engineering simulation and HPC that you're...
That is correct.
Focused.
It's engineering simulation and HPC. So my colleagues look after things like weather simulation, for example, or somebody else would look at EDA. So there are people like that looking at adjacent disciplines. I specifically look after the physics-based simulations, which is CAE, CFD. Sometimes there are like plasma physics simulations done by the new fusion companies and things like that.
Sure. And so do you see huge growth in engineering and engineering companies using AWS? And also then in particular, can you talk about what the trends are? Are there big technology hits that are going to improve things for engineering coming up?
Yeah, so we see that there are predictions that which I showed in my talk, that CAE and CFD, the engineering simulation workloads, are one of the fastest growing workloads on the cloud for HPC. HPC does other things also, like banking and financials, etc. Those have, or healthcare, drug discovery, there are simulations and things done for that. But amongst all of this, the physics-based simulations, which is CAE, CFD, has the fastest growth rate on the cloud. As per research done by Hyperion, which is a market research leader in the high-performance computing area. So we're definitely seeing a very fast growth of engineering simulation happening on the cloud. And what was your the part of the question?
Well, just thinking about in terms of future technologies that are coming, which will really deliver extra performance, I suppose, specifically for engineering.
Yes, so we are always working on the latest processors, for example. So computation really depends, the fundamental thing it depends on is the processors. So one of the things is we are implementing the latest processors, whether they're from AMD or Intel. Amazon creates its own processors. They're ARM-based processors.
Okay.
Yeah, these are called Graviton processors. Now Ansys LS-DYNA, for example, runs on Graviton processors.
Yeah.
So the Graviton processors are a unique innovation. They're also particularly good from a sustainability point of view because they can consume about 60% less energy than traditional processors. And as you know, data centers can be big energy consumers these days. So if our customers get chance to use processes that are consuming lesser power, then they can go ahead on their sustainability goals. So that's one of the innovations that's coming up. We are seeing GPU-based codes, like Ansys, different codes, Fluent has a GPU-based version. So those are coming along. Most of the times, the GPUs are typically used and designed for artificial intelligence workloads these days. So that's another technology coming up. In terms of services that we are building tools that make it easier for customers to deploy high-performance computing workloads on AWS. So, for example, in the past, we have had a tool called AWS Parallel Cluster, by which customers can very quickly, with a script, build a cluster for high-performance computing. That tool still exists. We now have a new tool called Research and Engineering Studio, which can be used to manage a fleet of virtual desktops. So engineers they can work from a thin client like a laptop and do all their pre-processing, post-processing, everything on the cloud, keep all the data in the cloud. So that's another one that's coming up. We've also been doing work on machine learning. In fact, next week we'll be publishing a paper at the Society of Automotive Engineers on various methods of machine learning for road vehicle aerodynamics.
Okay.
Well, I think you are aware that Ansys Fluent runs perfectly on GPUs. However, with the current shortage in availability, it's hard to sell those GPUs to customers. We simply can't provide them. How can you help?
Customers, a lot of times I've seen customers who would come to us to run their GPU codes because they're not able to find GPUs elsewhere.
Yeah.
So they can come to the cloud and
because you guys are buying them all, yeah.
Well, yeah. So the thing about the cloud, as I mentioned earlier, is you can use the pay-per-use model, right? So you can sometimes customers come and try out the GPU solvers first of all on a pay-per-use. They don't have to buy expensive GPUs, and they try them out on AWS.
So you're investing a lot to make technology available. So what do you think, what impact would that have for the product development process on the larger scale for the company and on a more personal scale for a simulation engineer?
For a large company, what the cloud provides is business agility. Suddenly a new product has to be launched. There is a tight timeline, and you need a surge of simulation. You can do that easily on the cloud. you can build up resources pretty quickly on the cloud, and you can dismantle them later on. Once that need has gone, then you can dismantle them and you're not paying for them anymore. So it gives a business agility, always staying with the latest technology, also makes sure for the company that they are getting the most utilization out of their software licenses. There are business benefits for the companies like that. And that's the reason why I see that there is a sort of a mass drive of customers who are coming to the cloud with moving their simulations over to the cloud. What this means at a personal level for the engineer is, first of all, they will have much better turnaround time and access, much faster turnaround time. They can run more simulations, they can run more complex models, get more detailed results out of their simulations. Also, they get exposure to the cloud, which with so much happening on the cloud these days, it's really good at an individual level to have some exposure to the cloud and to have some skills related to the cloud. So that's also a unique opportunity for simulation engineers to have that exposure to the cloud and some basic cloud skills.
Well, everybody is talking about artificial intelligence and machine learning. So why is engineering simulation still important for AWS?
In this artificial intelligence era, so AWS is doing a lot of things. More machine learning happens on AWS than anywhere else. We have different services like SageMaker or Amazon Bedrock or Titan for machine learning. But those are, like the large language models and things, a little bit different from simulation-related machine learning. So simulation-related machine learning is very nascent at this point of time. It's in early stages, how accurate it can be, how much training is needed. Those are some of the fundamental questions, or how wide it can be. Meaning, for example, if I create a trained model for a sedan-shaped car, would that work for a SUV-shaped car? Mm-hmm. So it's not very well known like that. So we are in the early stages of that. And Ansys has the SimAI product now that we closely work with Ansys on that. We have been working on trying out different methods on our own, like mesh graph nets and things like that, which I mentioned we will be publishing in a paper next week at the Society of Automotive Engineers. We are working with our customers to do these initial tests of how and where they can use machine learning. Initial work that we have done shows that if you train, again, I'll take the example of aerodynamics. You can run a number of simulations, say 50 simulations of aerodynamics around a vehicle, and you can train a machine learning model with it. Each of those simulations probably took 24 hours to run on 2,000 cores, maybe. But once you have a trained model, you can infer the entire flow field for a new design in 2 seconds. Yeah. It can be incredibly powerful, but what is the accuracy and how is the consistency of the accuracy? What we have seen is we are still maybe 2% accurate in the flow field, which is good for early design stages, but not good for the final design stages. Yeah, so again, simulation has to be run for the final design stages, but it gives engineers more flexibility in the early design stages.
Sure. And maybe just backing away from the technology a bit, talking about partnerships. How do you work with partners? How important are local partnerships to you? And then I suppose leading on from that, how do you see CADFEM and AWS partnering and delivering value to customers?
At AWS, we say that we are customer obsessed, but we are also partner obsessed. We depend very heavily on a very wide network of partners for helping our customers in the best possible way. We have over 90,000 partners. That number can give you an idea that we embrace partners and we work very closely with partners. We are looking forward to collaborating with CADFEM closely along with Ansys. This is a sort of a very close three-way collaboration between AWS, Ansys, and CADFEM. as I mentioned earlier, I've been observing CADFEM for 20 years. In my previous role, we've had a chance to work together, and we understand the deep reach that you have with customers in the DACH region particularly, and also around the world with your various subsidiaries. So we are looking to help your customers with the advanced technology that the cloud can bring to them to help their engineering simulation workflows.
So we have a joint job to do to inspire our customers that cloud is a solution.
Yes, and there are a number of case studies of how other customers are using simulation. So in my talk, I showed a slide where I showed some 30 different published examples of how different engineering companies around the world are using simulation. So this is already happening, and we all can work together with our customers to understand what their specific needs are and to help them out. So that's sort of my viewpoint. What's your viewpoint of how CADFEM and AWS can work together?
Well, I think we have so many customers that haven't even tried to go to the cloud because they're shy. We simply need to make it easy for them to start a job and to make sure they don't have to handle all the IT environment. So I think you provide the technology, we make sure it's available, and then I think we can help the customers together.
That's true. And then tools such as Ansys Gateway help in that to make the process easier.
Yeah, absolutely. I mean, so from my side, like we've been an AWS channel partner now for 10 years, and we have a platform that we deliver to customers at the moment. I think we were a little bit early, maybe. It's great to hear now that there's significant and fast growth in engineering companies adopting cloud. So I'm hoping we're going to benefit from that. We'll have a head start already. We see startups, I think, as a really nice focus area, because these are companies who are doing, from a simulation point of view, very challenging tasks. They need high-end computing, but they can't afford to buy a cluster. So I think that's a perfect place to start. But I mean, our ambitions go way beyond that, obviously.
Yes, yeah, startups are a great example because startups are typically born in the cloud, as we say it. Because like you said, they can't afford to make capital expenses for a longer term when they are in their early stages. So cloud is a perfect solution for them. They can come in and use the cloud services on a pay-per-use basis for their workloads. That's an excellent example. We're also seeing large-scale enterprises, companies that have been around for 100 years. They are starting to take a cloud-first approach now. They've realized cloud's been around for about 18 years or so now. Now the companies are realizing that the true benefits of the cloud and are confident enough to move to the cloud. And a lot of old enterprises are also taking a cloud-first approach and moving a lot of those things that they were doing on premises over to the cloud. So all the way from startups to the largest enterprises, even military organizations, governmental organizations, they are actively on the cloud these days. So there are a lot of customers for all of us to serve together.
Yeah, absolutely.
So it was really good talking with you. Thanks for having me here at the conference, and it's wonderful to see the conference again.
Thanks for coming to our conference as a sponsor with your team. So looking forward to further collaboration. Let's make cloud happen.
Thank you very much.
Thanks very much.
Thank you.